This $2 sheet of plastic cools your house forever with zero electricity. Why aren't we even using it? Stanford engineers proved it works in 45-degree heat, yet the AC industry has stayed silent 10 years. I have spent 30 years inside the heating and cooling business, seeing every gadget, refrigerant, and overpriced thermostat. What Stanford built in 2014 quietly rewrites the entire game. They cooled a real house using outer space. No compressor, no freon, no power cord. Just a thin film cheaper than basic plywood from the hardware store. The industry that should be screaming about this breakthrough has gone strangely quiet. Why? Let me show you first. First, let me show you exactly why your air conditioner is silently bleeding your wallet dry every summer. Look at your last electric bill. Now find the one from 5 summers ago. Notice anything alarming? For most American households, the summer number has nearly doubled. That is not your imagination, not inflation. It's the brutal price of fighting physics with a noisy metal box bolted to the side of your house. Air conditioning now devours 17% of all electricity generated across the entire United States. 17%. 1 in every 6 power plants exists essentially just to chill American living rooms each scorching summer. Meanwhile, the aging grid simply cannot keep up. Every heatwave, emergency warnings flood out across America again. Brownouts in Texas, rolling blackouts in California, emergency alerts in Arizona. The pattern repeats every single summer. Hotter weather forces more AC, which strains the grid, causing failures, making homes even hotter. Endless spiral. It is a death spiral written in copper wire and aluminum coils. And there's a stunning way out. A dirty secret nobody on the showroom floor admits. The refrigerant in your beautiful new heat pump leaks constantly. Slowly, quietly, invisibly. Gram for gram, those gases warm the planet thousands of times more than carbon dioxide. We are literally cooking the atmosphere to cool our bedrooms. The homeowner is trapped inside the cycle. You pay the utility, you pay the repair guy, you pay the planet itself. There is no exit door. But there is an exit. A low-tech fix older than your grandfather, older even than the light bulb itself. 2000 years ago, in the deserts of ancient Persia, engineers built shallow pools inside structures called yakhchals. At night, the water froze. In the desert, where daytime temperatures crushed 110 degrees Fahrenheit, no machinery, no electricity, just clay, straw, and a clear view of the night sky. How was this possible? Because the sky itself is cold, not the air, the sky. Space sits at 3 degrees above absolute zero, minus 270 degrees Celsius. An infinite bottomless cold sink hanging right over your head every single night, free for the taking. The Persians did not know the physics. They did not need to know it. They noticed flat water under an open sky cooled below the air temperature, and they built around that fact. The trick worked for centuries. Then we forgot. We poured concrete roofs. We sealed up all of our buildings. We turned to compressors, copper coils, monthly utility bills. The sky kept offering free cooling. We stopped looking up. Until 2014. A team of Stanford engineers, led by quiet professor Shan-Hui Fan, asked a strange question. What if we could pull the Persian trick during the day, in full sun? Physicists laughed. Math said impossible. Stanford did it anyway. They published, they patented, and then something curious happened. The patent went quiet. The press releases stopped. HVAC giants never licensed it. Why aren't we using it? Hold that question, because the physics is embarrassingly simple. Every object above absolute zero radiates heat. You, me, your roof, your car. Heat leaves objects as infrared photons. Most of those photons get absorbed by the atmosphere on their way up. Water vapor catches them. Carbon dioxide catches them. The heat gets trapped, bounced back down. Your roof never cools. But there is a magic window, a narrow band of wavelengths roughly 8 to 13 microns wide, where the atmosphere is almost completely transparent. Photons in that exact band shoot straight through the air, past the clouds, past the stratosphere, out into the freezing emptiness of space, where nothing sends them back. Scientists call it the atmospheric window. Think of it as an invisible chimney drilled through the sky, open 24 hours a day, leading directly to a giant radiator the size of the entire universe. Any object on Earth emitting strongly in that 8 to 13 micron band loses heat to outer space, forever, for free. Now here is the problem the Persians never faced in daylight: the sun, the deadly midday sun. In the day, sunlight pours down with about 1000 watts per square meter of raw energy. Any normal surface absorbs that, heats up, and the gentle trickle of radiated heat going out is overwhelmed by the fire hose of sunlight pouring in. The cooling effect disappears. That is why daytime passive cooling seemed impossible. Stanford's breakthrough was a film, a multi-layer stack of nano-thin silicon dioxide and hafnium oxide on silver, each layer engineered to a precise thickness. The stack does two miraculous things at once, simultaneously and silently. First, it reflects 97% of incoming sunlight, almost a perfect mirror. The sun's energy bounces away. Second, in the 8 to 13 micron window, the film becomes a champion emitter, pumping infrared photons skyward into space. Sun in, sun out, heat radiated to the cosmos. The film surface sits below ambient air temperature, in direct, brutal midday sunlight. Now the part the HVAC lobby really does not want known. Standard air conditioning is a constant battle. Your AC takes household heat and dumps it into hot summer air. The hotter it gets outside, the harder the unit has to work. Efficiency collapses on the day you need cooling most. This is why your bill spikes during heat waves. This is why the grid fails. This is why compressors die. Stanford's film does the opposite. It does not fight the heat. It hands the heat to a place always cold. Outer space does not care if it is July in Phoenix. Space sits at 3 Kelvin, always. 365 days a year. No moving parts, no fans, no pumps, no compressor, no refrigerant. Nothing to break, nothing to leak. No service call, no warranty bait and switch. Just engineered material doing photon geometry. And here is the part that should be on every front page. It works in full midday sun. Direct, undiluted, scorching summer sun. Measured surface temperatures sit 5 to 10 degrees Celsius below the surrounding air. 5 to 10 degrees colder than the air while the sun is hammering directly down. Read that again. A regular roof in the sun reaches 160 degrees Fahrenheit. A Stanford-coated roof reads 40 degrees cooler. The HVAC industry, refrigerant makers, utilities all depend on you needing more cooling, not less. Always more. A passive sheet costing pennies per square foot that never breaks is, to them, an absolute catastrophe to hide, so nobody mentions it. Wait until you see the actual efficiency numbers from Stanford's published lab measurements. The first prototype, tested under California sun in 2014, pulled 40 watts of heat per square meter continuously. By 2018, refined versions hit 93 watts per square meter every second the sun shines on it. A typical American roof has between 150 and 200 square meters of available surface area. Multiply 93 watts by 100 square meters and you get 9.3 kilowatts of cooling. That equals the output of a 3-ton central air conditioner running flat out, without a single plug. And it gets stranger. Stanford's team integrated the film with a thin water loop beneath the sheet. Water flowed under the film, got cooled below outdoor temperature, then circulated through the entire building's pipes. Real test homes saw a 21% reduction in total household energy use across a full cooling season. 21%. From a passive add-on with no moving parts touching the film, only one small water pump. Now the money. Raw materials for the film in the lab cost under 50 cents per square foot. As manufacturing scales, the price drops. Free startups are now producing rolls at industrial volume right now. Real installs are running between $1 and $3 per square foot, fully delivered to your door. A typical American roof, fully coated, lands somewhere between $1,500 and $4,000 after install. Energy savings on a hot climate home pay that back in roughly 18 months, less than 2 summers. After that, the film pays for itself. Then it prints money, for decades. With no compressor to replace, no filter to swap, no technician to call, just free cooling falling out of the sky, forever. But can a regular homeowner actually install it themselves? Stay with me, because the answer surprised even me. The current generation of products comes in 2 forms. The first is a flexible film that rolls out. It rolls out like contact paper. You clean the roof, peel the backing, squeegee it down. That is it. No specialized tools, no certifications. Any contractor with a ladder and squeegee can apply it in an afternoon. It retrofits onto asphalt shingles, metal roofing, flat commercial roofs, sheds, garages, mobile homes, anything with sky view. The second form is a hybrid panel. It looks like a solar panel from a distance, but cools water. A thin loop of glycol and water runs underneath the cooling surface. Cold water collects in an insulated tank. The tank feeds a small fan coil unit inside the house. You blow indoor air across that cold coil. Cold air comes out the vents like central AC. But the chill comes from the sky, not a compressor. Stanford built one of these systems on a test home in California. Standard wood frame house, standard insulation, nothing special. Then they installed the panels on the roof, ran the loop, and measured what actually happened inside. Indoor air temperature dropped 6 degrees Celsius in a single day, with the outside thermometer reading 35. No grid power, except a tiny circulating pump using less electricity than a charger for a laptop. 6 degrees of cooling from a roof retrofit in a regular house. The technology is real, numbers published. The average American household spends about $1,800 a year on summer cooling alone. Nothing else. Heavy climates like Texas, Florida, Arizona push that past $3,000 per year in cooling costs. Stanford's measured 21% figure stays conservative. Hot regions see 30 to 40% cooling bill reductions. Conservatively, in a typical American home, expect $1,200 a year saved. Some homes save much more. $1,200 a year. Over a decade, that's $12,000 untaxed sitting in your account. And that's just operational savings. Add equipment savings. No more $6,000 central AC replacement every 15 years. No more $800 service calls when the capacitor blows in August. No more refrigerant recharges every season. No more filter subscriptions. No more inverter board replacements. The film just sits there year after year, silently reflecting sunlight, radiating heat directly to the cold cosmos, costing you absolutely nothing year after year forever. This is what the title promised: free cooling, essentially free energy, a low-tech solution older than civilization itself. Finally weaponized by modern materials science and almost completely buried by the people who profit from your bills. So why isn't this on every roof already? Follow the money. Utilities sell you kilowatt hours, and lots of them. The average summer cooling bill in a hot state runs $300 to $500 every single month. If every Sunbelt home cut that by a third, regional utilities lose billions in annual revenue overnight. There is no commission paid for selling you a sky. No recurring revenue from a roll of film. HVAC manufacturing giants collectively defend a market worth over $200 billion a year. Compressors, refrigerants, service contracts, smart thermostats with cloud fees. A passive film needing none of them is the worst possible product. Building codes have not caught up either. The energy code has no category for radiative sky cooling yet. Insurance companies don't know how to underwrite it. Mortgage appraisers don't know how to value it properly. The whole regulatory apparatus is built around mechanical equipment, not passive films. Codes will take a decade. The industry doesn't want you to know you can install this on your house today as a roof coating. No permit needed in most places. The good news? The dam is finally starting to crack open. 3 startups are now shipping product in the United States. SkyCool Systems sells full hybrid panels commercially. Radicool offers roll-on films through specialty distributors. European and Israeli companies are now pushing into residential markets too. Pilot installs run at supermarkets, data centers and pharmacy chains where cooling loads are enormous and brutal. Once the warehouse next to your town reports 40% power cuts, the homeowner version becomes inevitable. There is also a second act to this technology, and it might be even bigger than the first. The same atmospheric window that lets heat escape on summer nights also lets warmth escape on winter nights, which means, paradoxically, the same physics can be flipped to harvest warmth for free during cold months. That is the subject of my next video: passive winter heating from the same sky that cools July. Subscribe so you do not miss it. One last thing before you click away from this video. If you take nothing else from this video, take this. There is a hole in the sky overhead. It has been there for 4 billion years. It will remain there for the next 4 billion. Through it, every roof on Earth has a direct line to a radiator the size of the universe. The ancient Persians used it. Stanford engineered it for the 21st century. The HVAC industry ignores it. You now know the truth. If you are interested in more low-tech solutions like this, please subscribe now. In the next video, we break down passive winter heating using this same atmospheric window technology simply. I will show you the simple panel design you can build yourself at home this coming weekend. Share this with anyone building a house, planning a renovation, or paying too much for summer electricity. The technology is real, the film is shipping, the savings are measured. One more roof is missing. See you in the next one. Subscribe.